find the, write out how it was transformed, give the domain the range, and then do a little graph. So.
Okay.
Alright, so my first one says -2. Secant, and then inside the parentheses, -4x.
Okay.
So that's what I got.
How can I rewrite that to eliminate the negative inside the parentheses?
You could factor out a negative.
Well, secant is the reciprocal of what?
Cosine?
Okay, what is cosine of -x equal to? Because it's an even function.
Oh, cosine.
Which means same for secant. So the secant of -x has to also be the secant of x. So I can just remove that instantly. Okay? Could look at it as a reflection over the y-axis, which is what it would be. But notice that if I take my cosine or my secant curve and reflect it over the y-axis, doesn't do anything different. In other words, it's a perfect reflection over the y-axis. That's why the cosine of -x is the same as the sine of -x, or the same as the cosine of x. It's also why the secant of -4x is the same as the secant of 4x. So that's the first thing I can do, is get rid of the minus sign. Now, we know that the secant sits on top of the cosine, right? Tops and bottoms. So if I erase the cosine, there's my secant curve, but that would be the secant of x. So what is the effect of, let's do the reflection first, always. So what's the effect of the negative sign out there?
It flips it?
Exactly. It reflects it over x.
Yeah.
So this is normally 1 to -1. So if we flip it, and then what's the effect of the 2?
It makes it the amplitude 2.
Okay, so instead of flip, it's a flip and a stretch. So the bottom one is going to be like that, and the top one is going to be, oops, go down to 2. So what I've just drawn would be this, -2 secant of x. What's the consequences of the 4?
Oh, it's the C over D thing, right? So you don't have a D, so you just need to do the...
4 is B.
Oh, so it changes your period.
Right. By a factor of...
1, 4? 4.
By a factor of 4. Is it a compression or a stretch horizontally?
A compression.
Yeah. In other words, when you're looking at this number here, a number greater than 1 is a stretch. A number between 0 and 1 is a compression. But when you're looking at this number here, a number greater than 1 is a compression. A number 0 to 1 is a stretch. So we have to basically take the curve we've drawn and squeeze it. Now, right now, I've got vertical asymptotes going through there, the way I've drawn it now, and that's pi over 2. So typically, if I'm drawing this curve there, It would be drawn just like that and labeled minus pi over 2 to pi over 2. Well, in our case, what are those labels going to be?
Pi over 8?
Yeah, minus pi over 8 to pi over 8. And then the period, well, the period would actually typically be 2 pi. It's now only pi over 2. So to get the pi over 2, I got to go out to 3 pi over 8 to draw my second curve. So now that blue and that blue, as long as this point is 3 pi over 8, and this point here is minus pi over 8, we have a period of pi over 2, which is what our period should be. And so the function I've drawn is minus 2 secant of 4x. And notice that if I did have secant of minus 4x, which was what the problem was, it would be a flip over the y-axis, which would be the same thing as what we're looking at.
Okay.
Because I have another leg over here and another leg down here. So if I take this and flip it over the y-axis, I have exactly the same thing I'm looking at. That's why the cosine and the secant are both even functions, meaning they are symmetrical with the y-axis.
Okay. Okay. And then for range and domain.
Okay.
That's...
What is the domain? Let's take the easy one.
Everything except for the odd multiples of
Yes.
pi over 8?
Yes.
Okay.
All reals except odd multiples of pi over 8, meaning 1 pi over 8, 3 pi over 8, 5 pi over 8. All of those are going to be vertical asymptotes. What's the range?
Numbers that are greater than 2 and numbers that are less than negative 2.
Yeah. So negative infinity to minus 2. So if I wanted to do it in interval notation, it would be negative infinity to minus 2 bracket combined with 2 infinity, 2 bracket to infinity, like that. So that would be the range in interval notation, because it can be equal to 2 and minus 2. Okay. Got another one?
Yeah, I have 4 of these. So the next one is negative 3 sine, parentheses, x over 4.
So A is 3. What is B?
1/4.
So what's the period?
1/4.
Now remember, the period is 2 pi over B.
So
In other words, remember this. The period is 2 pi over B, or B is 2 pi over the period. That's the same thing. So in this case, we know B, so we're trying to figure out the period. So if I substitute a 1/4 there, what do you get for the period?
pi over 8.
No?
Or 8 pi, sorry.
Pi.
Sorry. I
Okay.
don't know.
So I need to draw my curve, and I need to go up to 3, down to minus 3. My period, I'm going to start it, there's no phase shift, so I'm going to start it at the origin, and I'm going to go out to 8 pi. Beginning and ending of this curve. So without the negative sign, it would just be a sine curve drawn. In other words, I would quarter it up, let's go ahead and do that. What's the negative do?
Reflects it over the x.
Okay, so I've got to hit this point. I've got to hit this point. I've got to hit this point, and I got to come back down and hit that point. So
yeah. Okay.
what else?
3 cosine, parentheses, 2 over 3x, parentheses, plus 4.
Okay, so A is 3. B is what?
B is 2 over, no, because you have to do 2 pi.
Well, hold on. B is 2/3.
No.
Which
Yeah.
makes the period what?
What, 3 pi?
Yeah.
3 over, yeah.
And C is 0. No phase shift. But there's a vertical shift of 4. So in this case, what's the first thing you do to graph when there's a vertical shift? Normally we would have a line of symmetry that is the x-axis,
Yeah.
right? In other words, our curve is going to be equidistant above and below the x-axis. Well, when you have a vertical shift, you take your line of symmetry and you shift it by that. And you draw an imaginary dotted line there, up 4 units. Now, whatever graph I'm going to graph, I'm going to pretend that my dotted line is the x-axis. Okay?
Okay.
So, that x-axis is at 4. So what's my peak point and what's my smallest point going to be?
So your peak point would be 7.
My smallest point?
-1.
About positive 1.
Positive 1?
Yeah, because
Wait, what?
it's 3 units from 4 to 7, and it's 3 units from 4 down to 1. In other words, that line of symmetry has to be halfway in between my maximum point and my minimum point. Okay? My period is 3 pi. So if I go out to here and just label that 3 pi, now I got to quarter it. What's that point?
Wait. Oh. Quartering it or putting it in half?
Start by halving it.
Okay. So then it would be 3 pi over 2.
Okay, and then what's this point here?
3 pi over 4.
Okay.
And then in the middle it would be 9 pi over 4? Mm-hmm.
Yeah. And the way to figure that out is it's got to be half, add that, and divide by 2.
Oh, cool.
Okay? And that gives you that middle point. Okay, so now we got it quartered. We know where all of our points are. We know that cosine normally starts at the peak. So this point has to be on our curve. Comes down through the line of symmetry at the first quarter point. Goes down to the low point at the second quarter point. Comes back up through the line of symmetry at the third quarter point. Coming back to its starting point there.
Okay. All right. They're kind of hard.
Okay, what else?
4 sine Oh, don't pause. Parentheses 4 or pi over 4 x plus pi.
Ah, we got a phase shift now.
End parentheses minus 5.
Okay, so we got everything going on here. So let's first step.
Set up your little I want to call it
Line of symmetry.
the line of symmetry. Yeah.
Okay, there's the x-axis. The line of symmetry is 5 units below that. So the new line of symmetry is there. What's the maximum point?
-1. Right?
Huh?
Okay. And then the
Minimum.
lowest and minimum, yeah, is going to be -9.
What is the period?
Okay. Does the phase shift, it affects the period, right?
Okay, let's go back. What's B? B is always what affects the period. In other words, the real way to do this is to list A, B, C, and D. Okay, A is 4. B is what?
1/4.
Well, B is pi over 4, which makes the period what?
So 2 pi.
Divided by pi over 4.
So then you have to flip it. So it would be 8.
Uh-huh. Okay. C is what?
Pi.
Depends on what your standard is. Does your standard say bx plus c or bx minus c?
I don't really know.
It doesn't really matter as long as you know which. So we'll call pi the c. What's the phase shift?
1. I don't know. Pi.
If b is inside the parentheses, then your phase shift is c divided by b. Okay?
Oh.
So the phase shift is going to be c, pi, divided by pi over 4. That's equal to 4. Is it left or right?
So it's positive, which means it would go to the
Well,
left?
once again, it kind of depends on what your general format is. Yes, it goes to the left. As long as you know positive means goes to the left. See, the format that I'm used to is this one here. Y equals A sine B outside the parentheses, X minus C plus D. That's the formula most schools use.
Okay.
Some use this one. Y equals A sine, they put the B inside the parentheses, they make it plus C plus D. That changes everything. Now the phase shift becomes minus C divided by B. Whereas with this format here, the phase shift is C. Much easier. There's no division required. And both formats are proper. It just depends on the format you get it in. In other words, the one they gave it to you with B inside the parentheses. So if B is inside the parentheses, in order to get the phase shift, you do have to divide this C by B to come up with 4. Okay, so how do we start drawing this? What's the next step? If we know we have a phase shift of 4 and D of minus 5, Well, we've already got the d of minus 5 drawn in here. Where do we start the curve?
Well, you have to move it all over 4 to the left.
4 to the left. So I'm going to label that minus 4 right there. So this is where I'm going to start the curve, right where that x is, because I'm starting a sine curve. How big is my period?
8.
So I've got to go from minus 4 to 4. That's my ending point right there. Quarter it up. You got minus 2 plus 2. I've got to go up to minus 1, so this x is there. There's my second x. Come back down through the second quarter point. Go down, hit the minimum on the third quarter point at x equal 2. Come back up through there. Connect the dots. You want to use the same technique on every problem. In other words, start by moving your line of symmetry down. Find out A, B, C, and D. Next, start by accounting for the phase shift. That tells you your starting point. Use the period to get your ending point. Quarter it up, and you know that you hit your first high point at the first quarter. Back down through the line of symmetry at the second quarter, down to the low point at the third, back to the starting point at the fourth. You got one more, or was that the last?
Just like making sure the period. That's the last one I have. I just want to make sure you're never going to get anything funky with the domain and range, right?
Ah.
I mean, it'll always
Domain
be going by your asymptotes.
Yeah, I forgot about that. On this one, what's the domain?
All real numbers.
What's the range?
Anywhere between the -1 and the 9.
Negative 9 to negative 1. In other words, the interval is negative 9 to negative 1. Brackets, that's the range. Okay. On the other one, the domain is all reals. The range is from 1 to 7. It's only, the domain is only difficult when you have asymptotes. In other words, when you have something, well, the only two functions that don't have asymptotes are sine and cosine. All the other 4 trig functions all have asymptotes. Wherever sine and cosine is equal to 0, they have asymptotes. Well, if you have vertical asymptotes, then you're never going to be able to define your range as just all reals. It's going to be all reals except odd multiples of pi over 8, like you did on the secant. But on sine, there's no asymptotes, so it's all reals for domain, same with cosine.
Okay.
Did you have one more?
Those are the ones.
Okay. I suspect that might be the last one, because that one incorporates all 4 things. You can actually have 6 things going on, because I could put a negative sign in front of that, and I could put a negative sign in front of that. Then you would have to account for a reflection over the x-axis and a reflection over the y-axis. Or use the property of the fact that sine is an odd function. In other words, if I gave you this, y equals negative sine of negative x, well, I know that the sine of negative x is negative sine x, so negative negative, this whole thing would turn into sine x.
Oh. Okay, and then you just graph it like normal?
Yeah, that would be exactly normal. It would look like sine x. But the key thing to know is this. The sine of negative x is equal to negative sine x, as well as the tangent of negative x. And of course, each of their reciprocals is the same odd or even feature. But the one that's even is cosine of negative x. Cosine of negative x is just cosine of x. So make this cosine, and now that whole thing is equal to minus cosine x. Because this part here is equal to cosine x. So these bottom three are important. And something else that's important, let me just briefly mention it, is if you have something like the following. You have to do the following. You have to turn that into now you can,
Why?
well, because the angle that you're taking the negative of is x minus pi. In other words, notice I haven't changed anything. Those two things are the same. Distribute that negative sign, and you get the same thing as the top. But this is now the angle. And the sine of a negative angle is the same as negative sine of that angle. So when you have something like just a negative sign and a phase shift, and you're trying to figure out how to get the negative sign out from inside the parentheses, you have to do that process there. Add an extra set of parentheses, and then you have negative an angle. It's the same thing as negative the sine of that angle, and that angle is x minus pi. So this can be a little tricky if you run into something like this, the top line here. All right. But you didn't have any like that, so hopefully they won't give you any like that.
Yeah. That's good enough.
Okay? All right, Sarah, I will talk to you next Tuesday.
All right, thank you.
All right, bye-bye.
Yeah, bye.